Aloha, everybody. This is Rick Jones in Hawaii, and I want to talk to you a little bit about using discrepant events with your students. And I've got a couple of demos that I'm going to have you look at today. You'll notice that I'm using really pretty much simple stuff that pretty much anybody has. Well, it's really important that everybody remember that they need to have safety glasses if they're going to be playing with fire. I would prefer to use a Pyrex beaker, but unfortunately, the budget that I have is extremely limited, and so I have to use mason jars. But what we're going to talk about today is we're going to talk about fire. We're going to talk about the three legs of the fire stool. We're going to talk about centers of gravity or mass. We're going to talk about balance, torque, counterclockwise and clockwise rotation. We're going to talk about polymers. We're going to just talk about a bunch of different stuff. But I wanted to start off with the first one, and that is my kind of my getting everybody interested in thinking about what's going on and discrepant events. Students aren't really sure what I mean by a discrepant event unless you happen to be teaching high school with kids that are in like accounting, and they understand what a discrepancy is. It's like, oh, that's not what we expected. And so that's what we try to get them to think about. So we're going to take a look at what we have. We have materials. We have the beaker. This is a mason jar. I have flat wood toothpicks. I have a fork and a spoon. It's important that they're metal. And I have a box of matches. Now, I really do prefer to use the strike anywhere matches, but that sometimes causes a little bit of problem. So what I'm going to do is I'm going to put the spoon and the fork together by placing the two middle tines underneath the lip of the spoon and the two outer tines on the back side of the spoon. And I'm going to create a balanced system like so. Then I'm going to take the toothpick. I'm going to stick the toothpick between the two tines, the middle tines, and I'm going to find a point on here where I've got a fairly decent balance. And then I'm going to put that system on the edge of the jar. Okay, so first off, this is a challenge for a lot of students to do. It's a challenge for a lot of teachers to do. You need to have had some experience with a delinquent childhood, I think, in order to really make these things work. But we've got a system here where the center of mass of the system is right here on the edge of the glass. And the question that I ask my students is, what's going to happen if we light the toothpick on fire? And well, it's the question that I ask you. What's going to happen? Wait a couple seconds here, but the wood's going to burn. And it's not, there's no trick here. This is really what's going to happen. The wood is going to burn. And if the wood burns, what would be the expected event? Well, I think that you guys are probably pretty smart. You've probably already seen this, so you probably already know what most students are going to say. And that's what we're going to take a look at. So I'm going to light the match. You'd be surprised at how many students I have to show how to light matches. I'm going to light the match and light the toothpick on both sides. Pull it out. And we're going to go ahead and see what happens here. And what happens? The toothpick burns up to the contact point with the glass and with the metal fork, and it goes out. The main aha is it didn't fall. Why did that happen? Well, it happened because the fire went out. Now the question becomes, why did the fire go out? And lots of students that you have, many students that you have, and a lot of my students, I'd say well over 80%, the first thing they say is, oh, the air ran out. Well, the air can't run out because I'm still talking and I'm still breathing. So that's, and then I'll have them come up and take a look at it, and they can see that there's still wood. So if there's still wood there, that means there's still fuel. So we have the air, we have oxygen, we still have fuel what is it that's missing? What happened? What was taken away in this situation? And it takes some work to draw out that it's the heat. There's that third leg. Most of us don't think about the heat as being important here, but the heat of the fire is removed more rapidly by the glass than it can go into the wood. And the same goes for the metal. So we have different specific heats, which is really kind of an important concept for students to get to. So this is why a metal spoon in a drawer in the kitchen feels colder than a wood spoon in the same drawer sitting right next to it. They're both the same temperature, room temperature, but because they have different, they're made of different materials and have different specific heats, one pulls heat more rapidly away from your hand than the other one does. And therefore it feels cold because it's pulling heat rapidly. And that would be the metal, or in this case, the metal and the glass pulls heat more rapidly than the wood is able to. So that's my first really kind of discrepant thing. And of course, the students are like, well, why didn't it fall? And it didn't fall because all of the mass of the system is right here, which actually goes to the center of mass of the whole system, which is somewhere down below the table, towards the center of the Earth. In fact, it is probably the center of the Earth. So what we have here is a really interesting little activity. It's a discrepant event, and it ties into many things, many different aspects of science inquiry. And it's a phenomenon. This is a cool phenomena that can really jumpstart some discussions about different things. So I'm going to go ahead and pop this guy off of here, move it to the side, and I'm going to take a look at the other activity really quickly here. So the other activity that we have, and again, it's important that the students are wearing safety glasses, and it's also really important that you are aware of students that have any kind of allergies to latex. I really like to use latex balloons. Not every class. I've had a couple classes in the past where I've had students that had latex allergies. And so we just, I've got video of it. I can do it on video. It's not nearly as dramatic as for them to do it. But essentially what you've got for this is two different materials. You have a skewer and you have a balloon. And so I'm going to go ahead and blow up the balloon really quick. So I've got the balloon. It's about the size of an 8-year-old's head, maybe. That's how I kind of think of it. And we'll tie it off. And so what we have here is we have a balloon and we have a skewer. And the discrepant event is that most people understand that if you put a sharp object into a tight balloon, it will pop. But in this case, what's going to happen is that it's not going to pop. And that is a hugely discrepant event. And so the question is, what's going on here? Why did it not pop? And we can talk about what the balloon is made of. The rubber is a polymer. My analogy here in Hawaii is we talk about saimin or ramen noodle, and on the mainland, a cup of noodles would be a great example, or perhaps a bowl of spaghetti. So you have a bunch of spaghetti noodles up here in the bowl. You stick your fork in, and the fork stands up just fine, not a problem. All you're doing is pushing aside those long chain molecules. And then if you spill your spaghetti, your ramen, your saimin on the floor, the noodles, instead of being all intertwined like this, are spread out. There's actually some gaps. And when you push the skewer into the side here, where the polymers are already stretched to the limit, you tear them apart and they explode, they break apart. And so that's one of a really nice example of another discrepant event, because typically experience with pointy things poking into balloons is they pop. Now, another really cool thing to do with this, I'm going to adjust this just slightly up a little bit, there you go, is that now you actually can use this as an example of an Earth, and you've got your North Pole and your South Pole, and you can talk about seasons with it, because you can reference this as it goes around this would be the Earth going around the sun. Pretty slick. So in this case, where we would be looking at the northern hemisphere from the sun, and that would be summer. And I hate to just flip it, but this, you've got both poles, that's equinox. And then in this case, you've got majority of the direct sunlight would be on the south. And then again, you have equinox here. So you can use this for a lot of cool things too. And yes, in order to show that students that it is in fact going to pop, is that I can pull it out and we can stick this here on the side and it pops. And there you go, discrepant events, a lot of fun, cool stuff from around the house, and a lot of fun for your students as well. So hope you enjoyed that and have a great rest of the conference.